Alright, you are welcome to this lesson, and in this video we have been asked to check whether the function is continuous at x equals 0 and x equals 1. So first let's start with x equals 0. So at x equals 0, first of all check if the function is defined. We have three conditions for this. The first one says to check if f of a is defined, and this is x equals 0 and equals a. So f of a is equal to f of 0. Now at x equals 0, check our conditions here. Where do we have x equals 0? Here we have x less than 0. Excuse me, we skip that. Here we have, although 0 less than x, but we still have equal to 0 here. So because we have x equals 0 here, we use this function. So we have x squared minus 1 equals 0 squared minus 1 or equal negative 1. That's our first condition. The second one says we should check if the limits are equal, the right hand side limit and the left hand side limit. That is, we should check if the limit as x approaches a from the left of f of x is equal to the limit as x approaches a from the right of f of x. We should check if these are equal. Now let us check. The first one says the limit as x approaches 0 from the left. Now where do we have x approaching 0 from the left? When we see right and left, what do we actually mean? I will show you now. This is our number line, and this is where we have our 0. This is to the left of 0. This is to the right of 0. Now, as you can see, this arrow indicates the left of 0. This arrow indicates to the right of 0. So when you have x less than 0, this is the number line for x less than 0. Every value less than the value 0. Now what equation indicates x less than 0? This one. So you see x less than 0 here. So we can pick a sine pi x. So we have sine of pi x, which gives us sine of pi is a constant, which stands for 3.142 multiplied by 0, another constant, so which gives us sine of 0, which is equal to 0. Now for the right hand side limit as x approaches 0 from the right hand side will obviously be this, because after this where you only have 0 left is where you only have after this where you only have 0 left is here, and here is where you have this place says that 0 less than x, yes, which means that x greater than 0. If 0 is less than x, it means that x is greater than 0. X is greater than 0. So we pick that x squared minus 1, x squared minus 1. So we have 0 squared minus 1, which will give us negative 1. So as you can see, the third condition, which is the last, says that the limit as x approaches a from both sides of the function must equal to f of a. Now f of a is negative 1, and these limits are 0 and negative 1, which implies that the limit does not begin, does not end, does not exist to begin, does not equal each other to begin with. So you can say the limit as x approaches a from the left hand side of f of x does not equal the right hand side limit, which means that this will also fail, and we call such discontinuity a jump discontinuity. We get a jump when the limits does not match each other. So at this point at f of 0, the limit does not, the function discontinues. Now at x equals 1, at x equals 1, let's define f of a. Now f of a will be equal to, where do we have x equaling 1? Now here we have x equaling 1. We'll pick x squared minus 1. We'll pick x squared minus 1. X squared minus 1, which is equal to 1 squared minus 1, which is equal to 0. Now that is defined. Now 2, the limit must also exist. Now the limit as x approaches 1 from the left of where? From the left. This is obviously from the right, so this should be from the left. So we have x squared minus 1, which is equal to 1 squared minus 1 equal 0. And lastly, say we should find limit as it approaches from the right. So from the right will be this, which will be ln x. So we have the limit as x approaches 1 from the right of ln x will be equal to ln 1, which is equal to 0. ln 1 is 0. So we can see that f of a is defined. It's at 0. The limit from the left is 0, and also the limit from the right is also 0, which implies the third condition we give, that the limit as x approaches 1 from both sides of f of x is equal to f of a, which means this function is continuous at x equals 1 but discontinuous as x equals 0. Thank you, and see you in the next video. Don't forget to like and subscribe. Thank you.